Have you ever wondered what causes those massive sky-shaking storms? Why does lightning strike from the clouds? And what exactly is thunder? Today, we're exploring the electrifying science behind storms, from how they form to the mysterious dance of thunder and lightning. Let's break the storm down piece by piece. A storm is a disturbance in the atmosphere that brings intense weather, like heavy rain, strong winds, thunder, lightning, and sometimes hail or snow. But what causes it? It all starts with one key ingredient: heat. Warm, moist air near the Earth's surface rises. As it climbs higher into the atmosphere, it cools down and condenses into clouds. But not just any clouds, storm clouds, also known as cumulonimbus clouds. These towering giants can stretch over 10 kilometers into the sky. That's higher than Mount Everest. Storms form when the following three main ingredients come together. 1. Moisture, usually from oceans, lakes, or humid ground. 2. Instability, warm air rising and cool air sinking. And 3. Lift, something that pushes the air upwards, like a cold front or mountain. As the warm air rises, it cools, and the moisture condenses, releasing heat, which causes even more air to rise. This creates a powerful updraft. The cloud grows, thunderheads form, and the stage is set for lightning. Lightning is nature's way of balancing out electrical charges. Inside the storm cloud, tiny ice particles and water droplets crash into each other. These collisions build up electrical charges, positive charges near the top of the cloud and negative charges near the bottom. Eventually, the charge becomes so strong, it needs to discharge fast. A bolt of lightning is the result. It can travel between clouds, inside the same cloud, or between the cloud and the ground. And get this, the average bolt of lightning is 5 times hotter than the surface of the sun, reaching temperatures of up to 30,000 degrees Celsius. If lightning is the flash, thunder is the boom. When lightning streaks through the sky, it superheats the air in its path in a fraction of a second. This causes the air to expand explosively, and that rapid expansion creates a shockwave. That shockwave is what we hear as thunder. Here's a cool trick: you can estimate how far away lightning is. After you see the flash, count the seconds until you hear the thunder. Divide that number by 5, that's how many miles away the storm is. So if you count 10 seconds, the lightning was about 2 miles away. Not all storms are the same. There are several types. We have thunderstorms, the most common. They usually last less than an hour but can pack a punch. And then there are supercell storms. These are the most dangerous, with powerful rotation and the potential to form tornadoes. We also have tropical storms and hurricanes. Born over warm oceans, these massive systems can span hundreds of miles. Lastly, we have winter storms. Instead of rain, they bring snow, sleet, or freezing rain, often with strong winds. Lightning seeks the shortest path to the ground, especially through tall objects. That's why trees, skyscrapers, and communication towers are frequent targets. But lightning doesn't always strike the tallest thing. It targets the fastest and easiest path for the electric current to move. That's why it's important to stay away from open fields, metal poles, and even water during storms. All are great conductors. And yes, people can get struck. About 240,000 people globally every year are hit by lightning. Fortunately, most survive, but the effects can be long-lasting. Here are some cool storm facts you might not know. Did you know that the average thunderstorm produces around 100 bolts of lightning? Or that the longest recorded lightning bolt stretched over 477 miles? That's like lightning from New York to North Carolina. But if you thought that was intense, did you know that other planets have more hectic storms than Earth? Take Jupiter, for example. Its lightning is 1,000 times stronger than Earth's. Storms may seem destructive, but they play a vital role in balancing our planet's atmosphere. They move heat, distribute moisture, and even help fertilize the soil with nitrogen from lightning. And while we often fear them, storms are also one of the most fascinating displays of nature's raw power. So the next time you hear thunder rumble or see lightning flash, remember, there's an incredible science show happening above your head. Thanks for watching. If you learned something new today, give this video a like and subscribe for more bite-sized science explained. Let us know in the comments. Have you ever seen a lightning bolt up close? Stay curious, stay safe, and keep watching the skies.